Hello, welcome back again to another episode of SCADA 123. Today we're going to continue on our data log part 4 to get into the file and analysis with the SQLite and the stats that you've talked about and seen before. Now let's start with our SQLite. Begin with, SQLite is a little bit different from a lot of databases people are used to. Number one, it's an application, not a client server, so you don't have any complexity of connecting to anything. This is the path to the actual database that is stored on the local hard drive. In this case, it's your Raspberry Pi. Now, you can load it simply by clicking the load. You've got all the options of what type of file you want to load, but since we're dealing with SQLite, we'll load it as SQLite. Now you've got other two options here on which table you want to use. We have the MCC, which is all your analog values, and if you click that, we've got our GPIO here for all your digital values. Now it's got database is the same name. For GPIO, the table is GPIO, and the SQL columns, you got your D1s through 12. If we click that again to go back to our MCC, you can see same data name, but our table name is different and the SQL column names are different. These are all our analog values. Let's play with the analog, so we'll just click load. Okay, now you see you've got all the analog values here in the spreadsheet. You've got the data you can see here, and you can see it in the bottom of the IDE as well. So let's clear this out so we can see a little bit of what's going on. Now to begin, you can do a SQL command. This doesn't actually do anything but generate the command. It's a SQL command, so you can look at it and verify that that is what you want if you know SQL, and if you don't, well, it just kind of shows you what it needs. So it says select all, which is the star, from the table MCC 118. If we click read, it will execute that, and you'll basically see all the data. There you go. It's in the IDE. You've got a list. You can compare it to your spreadsheet. It's the same thing. So let's work a little bit deeper in here. The beauty of SQL, instead of like your historians where all you got to do is you scroll back and forth if you want to see some weird glitch or something like that, what you can do here is use the strength of SQL commands. You can check where the time is a certain period. If you knew something happened between 11:08 and 11:14, you can enter that in your time and it will refine all the data to within that period. Now let's say we want to go back. We only want to look at stuff that's 11:08. So now if we click on the use date time here, it's going to use the values that we have here. If you run the SQL command, it will generate the SQL command for that. Select all from MCC where the time is between. Now you'll see these weird and long integer numbers. What those long integer numbers are is the Unix epoch time. That's basically the number of seconds since January 1st, 1970 to the current date. That's why it's a big number. So if you're not sure what that is, what that means, you can just basically use the bottom here to convert it. So let's just do that real quick. We'll copy the data from what the begin date is, and let's enter that in. Now this is a real, so let's just get rid of all that extras, keep it as an integer and say convert. Okay, we converted it. You can see down the value of the IDE. You can also see here you've got 2020 11:08 11:58 is when it began. So you know you're going to get something there. You've already created the SQL. Let's read it, see what it says. Oh, here you go. So you got your data down there you've seen in the IDE. You've got 10 values out of 92. So you've seen you've already selected a bit right there. Now let's refine this a little bit more. Now let's use this where, and you can select any of those input values there. Let's just say we want to do, if you look at the data here at A6, you've got a little change here, as well as A4 from 1.7 to 2.9 and 1.7 to 0.9. So let's look at A3, where A3 If we want to exclude the 1.74, let's just call it 3. So let's look at values between 3 and 4 for A3. So we will generate the SQL command, scroll down to see what that looked like, select all from where time, we're still using the time, and our input 3 is between 3 and 4. So if we clear this out, and now let's read this, boom, we didn't get anything because it did not like that. Well, let's just omit that and let's read the command. Okay, so there we go. Now we got a whole bunch of them. One of the good things, I suppose you can say, is when you mess up like that, the computer will tell you there's no data there. So let's just expand this a little bit more here, shall we? We'll just take it to its current date. And if we use the date time, let's try that again. SQL and read, boom. Now you've got 80 values, 81 rows. You basically have most of it, which kind of tells you that most of the data for A3 seems to be around in 366 value. So let's try this. We're going to get a little bit more complex. Now our A6 also varies a bit here. So let's say we want to do our A6 where the value, and you can see this is just below 1, a little bit there, this is way above. So let's say we want a value of 0 to 1 to pick out all those 094s. We'll leave that 0. Let's just change this to 1. Now these three are all selected, so let's clear this out, run our SQL command. Okay, this is what we got. Wow, that's a biggie, huh? Select all from MCC where the time is between these two epoch values and input 3 is between 3 and 4 and input 6 is between 0 and 1. Let's read that and see what happens. Alright, we got 48 values you can see here. So that's a little bit of the strength there of SQL, and you can add more, make it more complex, simplify it. But instead of going through your standard historian, which is only going to scroll back and forth for all the values you want to see type stuff, and it can be a real pain if you're looking for a glitch, here you can just do a quick SQL command. If you know the time that's happened, you can put it in there. If you know just what you're looking for, it may be something like a totally out of range thing. Everything's below 5 normally. Suddenly you got something that's above 5. So you just select 5 to 10 and you'll find all those anomalies. Now, one more thing we can do to get a little bit more elaboration is we can check out the stats. Now the stats are basically included Panda Descriptive Statistics. Now there's divided in two as well because you have analog values that you can use the standard data type statistics where you can have a min, a max, and there's quartiles and means, and it all makes sense because you got data that varies within a range. Now for your GPIO that's all data, going from 1 to 0 doesn't really make a whole lot of sense doing a quartile or anything like that because it's a 1 or a 0. So to kind of get some information on binary data, you can just do the mean on all of these, and that will tell you how much is it currently on. 0 being always off, 1 being always on, and your mean is going to tell you how often in between. Now you can elaborate a lot more with binary data, but just to keep it simple for this application, that kind of gets you there. So you can compare your digitals of assuming your outputs and inputs should match. You can check the means to make sure that the means are the same. So let's start with getting some of our analog information here. Let's do the same again. We're going to click on our MC118. We've got that same file. We'll do a panda read. Let's load in all that. Okay, we got that same data again that we had in SQL. So now let's get our index, and you can see it finds and brings in all the column indexes there. So at that point you can then select your index. You can't really do the statistic values on every column simultaneously without taking a huge amount of screen. So you'll have to do it individually one-on-one. Now, we looked at A3 before to see the difference between 3 and 4. So let's take a look at that statistically speaking. We'll describe that by clicking the button there. So now you've got 92 values. The mean is 3.4. It's got a standard deviation of 0.6. Your low value was 1.74. Your max value was 3.668. You can see it didn't really vary a whole lot in the quartiles either, which kind of tells you it's pretty skewed. Of most of the data is basically around here on your max value, which makes sense with a mean of 3.4. So it's not anything dramatic, but it helps if you're trying to look at and analyze how things are running. Hope this helps. If you like, download this program on the link below. Thanks a lot. Appreciate it. Bye-bye.